Hi guys, Digital Principal and Computer Organization. The subject code is CS3351, second unit, Synchronous Sequential Logic. In my previous part second video of second unit, I will explain up to types of flip-flop. In this video, this part 3 video, I am going to briefly explain about what are the types of flip-flop. Usually, the types of flip-flop is classified into 4 types. SR flip-flop, JK flip-flop, T flip-flop and T flip-flop. In this video, I am going to explain you the excitation table, truth table, logical circuit and characteristic equation of this flip-flop, SR flip-flop. First one is SR flip-flop. So SR flip-flop is also known as set reset flip-flop. It has two set reset flip-flop. It has two input. One is yes, that is set, and another one is R, reset. And it's going to provide us two output. One is Q, that is present state output, and that is Q dash, that is next state output. If you give S is true means you will give a value of S equal to 1 and the output Y, that is present state, will be 1 and the Q dash will be next state is 0. Flip-flop is constructed with the clock. Truth table of SR flip-flop. So usually we have two input, one is S and R, and the final output is Qn plus 1, that is next state output. If you give S equal to 0, R equal to 0, the Qn plus 1 is going to give a value with the help of the present state output, that is Qn, and it is in hold state condition. Afterwards, if you give S equal to 0 and R is 1, that is I value, so it is known as reset state and the output will be given as 0. When S equal to 1 and R equal to 0, here S is given with a high value, so it is in set state. And S equal to 1, R equal to 1, invalid state. So if you give input as 1 and two input as 1, that is S equal to 1 and R equal to 1, it is giving you the indeterminate state. We can't able to predict the output when both the value will be given as high. So this state is known as indeterminate state. Characteristic table of SR flip-flop. First of all, you need to draw the characteristic table. Afterwards, you need to design a K-map with the help of this characteristic table and write down the characteristic equation with the help of the K-map. First, characteristic table. So, consider this three variable to provide an equation of Qn plus 1 as output. If you have three variable means, you need to first fill the first variable with 4041. After the second input variable with 0011, that is 2021. And the Qn is filled with 0101. If you give three values as 0, then the Qn plus 1 value is 0. If you give S equal to 0, R is 0 and the Qn is 1, the Qn plus 1 value is 1. Like that, you need to fill all these conditions when S and R will be in is given with a high value or with 1 means you will get a value of indeterminate state. Okay, this is the rule in SR flip-flop. So this is three variable S, R and N. If you have three variable means you need to draw the K-map for 8 cell, that is 2 into 2 to the power 3, that is 8 cell. Mm, and this row is, you will have two rows, that is 0 and 1. This yes, one of the variable with yes, and the q r and qn, 0 0 0 1 1 1 1 0. You need to fill this cell with 1 and don't care condition. Wherever the n was placed, this is 0th place of K map, 1, 2, 2, 3, 4, 5, 6, 7, 7. This is the 1 is in first K map cell and in fourth cell, fifth cell, and don't care condition in sixth and seventh. So fill the variable wherever the place. So fill the variable, fill the 1 in first cell value in fourth and fifth. Afterwards, fills the don't care condition in sixth and seventh. In this K map, we can able to form the two group. One in horizontal group, that is S, and another one is vertical group, that is Q dash or N. Here the R value is 0 and the Qn value is 1. If we have 0 input, 0 value for input variable, so you need to mention that input variable with dash, or it is complement of that given variable. That's why this is R dash, and the Qn value is 1. That's why you need to mention this Qn as it is. Okay, and this is n because it is grouped with in s when s equal to 1. That's why this is s group. Finally, you need to write the equation with sum of product method, s plus q dash n, or sorry, r dash n into qn. Qn plus 1 equal to s plus r dash qn. So s is the one of the grouping, and r dash qn is the another group. Another group. This is the characteristic equation of SR flip-flop. Excitation table. Why we need to use excitation table? For a given combination of present state and next state, that is Qn plus 1, the excitation tells the input required. In flip-flop, you will have two output state, right? So with the help of the excitation table, we will find out the requirement of the input. So this is the use of excitation table. The procedure followed in the truth table is, you need to apply that procedure in opposite way. This is the truth table of SR flip-flop. Here you will mention that S and R as input and Qn plus 1 as output, right? Here you need to find first two column is filled with Qn and Qn plus 1. Afterwards, write this S and R as input of SR flip-flop. The Qn and Qn plus 1 is filled with 0 0 1 1, and Qn plus 1 is filled with 0 1 0 1. If we give 0 and 0, the input of the S is going to be 0 and R it is in don't care condition. If you Qn as 0 and Qn plus 1 is 1, and the input of the S will be 1 and R will be 0. So Qn is 1 and Qn plus 1 is 0. The S is 0 and R is 1. Qn is 1, Qn plus 1, n plus 1 is 1, and it is in the indeterminate form, and R is equal to 0. You will also fill with this or S and R column with the shortcut of 0 1 0. Afterwards, write this values in reverse order for R, 0 1 0 and X, right? And you will write it as in reverse order, means first it will be filled with X, Afterwards 0, 1, 0. And what is meant by excitation table is one of the important 2 mark asked in your university exam. How will you construct the SR flip-flop? You can able to construct the SR flip-flop by two method. One is by using the NOR latch and another is by using the NAND latch. This is the logical diagram of SR flip-flop. This one is used by NOR latch. This is the NOR gate, right? And this one is NAND gate, NAND latch. And this is called as flip-flop. And this flip-flop is connected with the two input, that is S and R, with the help of clock. Likewise, so this is the flip-flop and this flip-flop is connected with the two input of S and R. So here we will use NAND gate and here we will use the AND gate, and it is going to provide an output of Qn and Qn bar, that is present state and next state output. In exam point of view, either you will draw any one of the logical diagram. It is more than enough. What are the advantages of SR flip-flop? It is The SR flip-flop is simple to design and analyze the output, and it is higher speed to provide an output, and it also consumes low power for its operation, and it also have the availability of battery power device, so it will store the power to provide an output, and it provides a bistable operation that it allows hold it one state infinitely. What are the limitations of SR flip-flop? Limitation mean drawback or disadvantage. When both the input S and R is given with high value, you will get a value of invalid state. And SR flip-flop cannot be used in highly complex digital system. If the very big system or some other difficulty in the system means we can't able to use this SR flip-flop, and it will provide an more error, and it also provide an unpredictability of output state. What are the application of SR flip-flop? The SR flip-flops are used in various digital systems like register, RAM to store the binary information, and it also used in the counters and data synchronization digital system, and SR flip-flop also used in control system. JK flip-flop were constructed used to remove the drawbacks of SR flip-flop. So SR flip-flop has some drawback, and with the rectification of the SR flip-flop, the JK flip-flop was designed. It was designed by doing some of the modification in SR flip-flop. When S and R input as true, that is one value, we can't able to determine the output of the SR flip-flop. We can't able to find out the output of the SR flip-flop when S equal to 1 and R equal to 1. So that condition is known as indeterminate condition. But in case of the JK flip-flop, it gives the correct output, whether it is 1 or 0. In JK flip-flop, both of the input are different. The value of the J at the next clock edge is taken out by the Y. If both of the input is low, that is 0 is given for J and K input, there will be a no changes is occur in JK flip-flop, and it is high at this clock edge from one state to the then from one state to the other, the output will be toggled. Finally, the JK flip-flop behaves the condition of S input, and the K behaves like the condition of R of the SR flip-flop. So J is going to perform the set operation of SR flip-flop, and the R is going to perform the reset operation of and K is going to perform the reset operation of SR flip-flop. This is the logical symbol of SR flip-flop. It has two input. One is uh, J and another is K, and it is clock. It is connected with the clock, and it's going to provide you the two state output. One is present state and the next state. State is Q and the next state is Q bar. Truth table of logical JK flip flop. As usual, J is filled with 2021 and K is filled with 0101. Qn plus 1 is the output of this JK flip flop. That's why we will mention in the truth table. So if you give J as K 0, K as 0 means the Qn plus 1 is provided with the help of the Qn. This is present state. The next state output is given with the help of the present state output. Afterwards 0 1 means the Qn plus 1, that is next state output will be 0. So it is in reset condition. And 1 0 means the output will be 1, and this is in set condition. If you give J1 and K1, both will be high, you will get an value of Qn plus n dash, that is in toggle state. In SR flip-flop, here we will have indeterminate, but here we will get an Qn dash as the output. JK, Qn and Qn plus 1 is the output. This characteristic table is defined is help to design the K map. Afterwards, this K map is you help to derive the logical expression. J, K and Qn here, this three variable is considered as the input and this is considered as the output. If you have three variable, how will you fill this truth table? So, first variable is filled with 4041 and the second variable is filled with 0011 and the third variable is filled with 0101. Afterwards, you need to find out the output of this variable. If you give three input variable as 000, you will get an output as 0. If you give 001 value, and you will get an value as 0. If you give 010 and you will get value as 1. Likewise, you need to fill all those 8 values. So, this 0 value in the position of 0, place 1, 2, 3, 4, 5, 6 and 7. Okay, if you have three variable means how many cells you want to design a K map. With the help of this formula 2 to the power 3. 3 is the number of variable. So you will find out the 8. You need to draw the 8 cell K map. So row is filled with Qn and the column is filled with JK value. Still 0 and 1. This is Qn and this is Qn. If 0 means you need to give the complement of that variable. This is qn dash. 0 is qn dash. Likewise, this is j dash k dash j k j dash k j k, because both the value will be 1, and this is j k dash. And fill this all fill this one output 1 in respective cells. See here where you will get a 1 as the output. One is this in the second cell and in third cell. So fill that second and third cell with 1. Afterwards, in fourth cell also you will have 1. So fill here 1, and there will be one more 1. It is in sixth place. So fill in the sixth cell, that is 1. Afterwards, you need to do the grouping. See here, here you can able to form two grouping. One is this is vertical grouping, and if the one in the corner cell, you can able to group this corner cell as one group. So this and this one will be considered as another group. So there will be a two group. One is this and another one is this. And write down the equation for the first group. So this in take down the value. See here in both, compare this both the value, and if you have different value you need to cancel out. So for first one, what will be the qn value, that is 0, and what will be the j value, that is 1. Afterwards k value is 1. Okay, then for this one, so this one, what will be the qn value 0, and what will be the k value 1, what will be the the j value is 1, what will be the k value is 0. So this is qn value, this is j value, this is k value, right? So I am find out the equation for first group. Okay, so see here, compare this both the value, this both will be same, 0 1. So write as it is, and this will be different, so you need to cancel it out. So write it down. This 0 is k q n dash, right? q n dash, and this 1 is in the j value. So you need to, if the 1 means, you need to represent as the variable itself. So write it as j. So this is, we will find it out. That's what here mentioned. So this equation is j into qn dash. Likewise, you need to compare this two ones value. Afterwards, you will cancel it out, means you will find out k dash qn. Then you need to write this equation with the sum of product. So qn plus 1 equal to j into qn dash plus k dash into qn. Why we will write here k dash means, see here, this one is 0, k value is 0 here, and here also k value is 0. If the 0 means, you need to mention with the complement, and if it is 1, qn value is 1, that's why we will mention with qn. So this is the characteristic equation of jk flip-flop. This is the excitation table of jk flip-flop. jk flip-flop, excitation table is opposite to truth table. So first column is filled with qn, second column is filled with qn plus 1, and j and k is the output. So what will be the output is going to happen if you give this as the input. qn is filled with 0 1 0 1, and qn plus 1 is filled with 0 0 1 1. Afterwards, for j is 0 and k is in don't care condition. If we give 1 0, the j is in don't care condition. We can't able to determine, so it is in indeterminate form. and k it is in one value. Likewise, we will fill this excitation table. So j column is filled with 0, x, 1, x. So you need to reverse this values for k. See here, this k x is comes here and this 1 is come here and this x is come here afterwards. So you need to reverse that k values to j values to k values. Construct the jk flip-flop by using NOR latch and NAND latch. It is similar to the SR flip-flop. In SR flip-flop also we will construct this flip-flop by using this two latch. So this is the JK flip-flop by using NOR latch and this diagram is JK flip-flop by using the NAND latch. So here you will give an two input, one is J and K, and you will get an two output as one is present state output that is Qn and this next state output that is Qn dash. See here, this is the NOR latch, this is NOR gate, okay, and this is NAND latch. And this latch is connected with one of the J input and another with the K input. In exam point of view, you will draw either one of this JK flip-flop. It is more than enough. First one is the toggle capability. In SR flip-flop, there will be a state of indeterminate, but here it can able to manage to the toggle capability. So here we will have no invalid state like SR flip-flop and it has reduced race condition compared with the SR flip-flop and it also function in the bistable operation. This advantage is similar to SR flip-flop. And these are the limitations or disadvantages of JK flip-flop. One is complexity and it is very complex for some of the flip-flop and it consume more power compared with the other flip-flop. It consume more power compared with the other flip-flop. And there will be a propagation delay in JK flip-flop and it is limited scalability. So it is difficult to scale up for more complex digital system. And there will be a occur of more error in JK flip-flop. And these are all the application where we can able to use it in counter. JK flip-flop is used in counter and it is used as a data storage device and it is also used for synchronization and it is used in frequency division. Used to create a frequency divider in which the circuit divide the frequency of the input signal by a fixed amount. So this JK flip-flop is used in the real-time application like audio and video processing. These are all the application of JK flip-flop. SR flip-flop versus JK flip-flop. Most of the functions are similar in SR and JK flip-flop. There will be only few difference between them. In JK flip-flop, the indeterminate state is not exist. Instead of indeterminate state, we will have the toggle state. So, this can be seen in the word of when the present state get inverted when both the inputs are 1. That means, so this present state get inverted value when j is equal to 1 and k is equal to 1. So this is called as toggle state. In SR flip-flop, if Si equal to 1 and reset equal to 1 means you will get an indeterminate condition.